Okay, so let's get started. Okay, and we'll start with a very basic thing that we've done million times in our lives, which is subtraction, right? So I'll give you a small subtraction and tell me the answer for this. 62439 minus 37285. What is the answer?
So 25154.
Okay, who was that? Was it Dia?
Yes, sir.
Okay, and Sudeepa, you also got it?
Yes, sir.
Okay. It took you almost about 25 seconds, right?
Yeah.
To get the answer. Now just watch what I do, okay, and tell me what I'm doing. What did I do? Okay, let me explain this. So we normally do a subtraction in the traditional method, right? And when you try to do that, sorry, who just joined?
I'm wishing.
Okay, Oishi, can you just turn off your video because we'll not need that. It kind of blocks the bandwidth, right?
Okay, okay,
We'll
okay.
not need the video. So you can turn off your video, just be on the audio mode. Okay, so coming back to this, so if we do this in the normal way, so 9 minus 5 is 4, and then 3 minus 8 means I have to take a 1 here and do a 5 here, and so on, right? So that takes a lot
Yes,
of
sir.
time. So what we do, this is called 62439 37285. So what I did is called vinculum maths, and this is very effective, especially when dealing with large numbers, which is very common in any competitive exam. So what I did was I just subtracted each number from the other one. So 6 minus 3 is 3, 2 minus 7 is minus 5.
Right.
So instead of minus 5 I put a 5 bar. 4 minus 2 is 2, 3 minus 8 is minus 5, and 9 minus 5 is 4, right? So this is the first step I wrote, and the second step is wherever I have a bar, I will subtract that from 10 and subtract 1 from the previous number. So I know I have to subtract 5 from 10 and reduce the previous number by 1. So 3 becomes 2, this becomes 5, this becomes 1, this becomes 5, and this remains as 4. Make sense?
Yes, sir.
Okay. Probably it's not very clear with even this number, but let us try a bigger one. Let's say we have 825396 18724, and we want to subtract 24365 709 362. Anyone with the answer? Not yet? So now you understand what is the use of this method. See how easy it becomes. 8 minus 2 is 6, 2 minus 4 is minus 2, 5 minus 3 is 2, 3 minus 6 is minus 3, 9 minus 5 is minus 4, 6 minus 7 is minus 1. I'm sorry, 9 minus 5 is plus 4. 6 minus 7 is minus 1. 1 minus 0 is 1. 8 minus 9 is minus 1. 7 minus 3 is 4. 2 minus 6 is minus 4. And 4 minus 2 is 2. Right? So even with this huge number...
The answer is...
Sorry?
Can I say the answer? Can I say the answer?
Yeah. Tell me.
It's 52133101 342.
No. The answer would
No,
be...
it's 5. Okay, sir. So you can continue, sir.
Yeah, so that's why I'm showing this method, because this is very effective and chances of going wrong are very, very less. Okay. So what did I say? I said wherever I have a minus sign or a bar sign, I will start from the left. Okay. And wherever I have a minus sign, I'll subtract that number from 10. So I'll subtract 2 from 10 mentally. So I know this is 8. So if this has to be 8, I have to subtract 1 from the previous number. So 5, 8. Then again, I have a 3 bar here. So this will become 7. I have to subtract 1 from this. So 1, 7. I have a 1 bar here. So this becomes 9. And 4 becomes 3. Right? I have a 1 bar here. This becomes 9. 1 becomes 0. A 4 bar here. This becomes 6. This becomes 3. And this remains as 2. Clear?
Yes, sir.
Shall I go through it once more?
Yes, sir.
Okay. So what you do is you just go subtracting the numbers directly. So 8 minus 2 is 6, right? What is 2 minus 4? 2 minus 4 is minus 2, right? So instead of minus 2, we will write this as 2 bar. Sorry, who just joined? Kindly put off your video. We will not need the video. The video actually slows up the bandwidth. So we will not need the video. You can just be on the audio mode. Okay. So coming back to this. So 2 minus 4 is minus 2. We write that as 2 bar. 5 minus 3 is 2. 3 minus 6 is minus 3 or 3 bar. 9 minus 5 is 4. 6 minus 7 is 1 bar or minus 1. 1 minus 0 is 1. 8 minus 9 is again 1 bar or minus 1. 7 minus 3 is 4. 2 minus 6 is minus 4, which is 4 bar, and 4 minus 2 is 2. So this is my first step. The second step is wherever I have a bar, I will subtract that number from 10. So 10 minus 2 is 8, and we start from the left. So 10 minus 2 is 8, so this will become 8, and the previous number will get reduced by 1. So 6 minus 1 is 5. Next I go to 3 bar, so this becomes 7, 2 becomes 1. Next I go to 1 bar, so this becomes 9, 4 becomes 3. 1 bar, this becomes 9, 1 becomes 0, 4 bar becomes 6, 4 becomes 3, and 2 remains. Clear? Clear? I'm anyway
Yes, sir.
Yes, sir.
I'm anyway going to share this video with all of you so that you can go through it again. But this is a very, very effective method when you're dealing with numbers, especially in competitive exams, because you won't get time. I mean, if you get a large number to subtract and you consume around 20-25 seconds, then you're losing time. So this method will help you do it in less than 5 seconds with a little bit of practice. Okay, as you can see. Okay, next we will do some multiplication. Okay, so tell me, how do you multiply 96 into 91? What is the answer?
Eight seven three six.
80
8736.
8736. Okay, let's see. There's a very simple way to do it. So whenever you have numbers which are close to 100, okay, like we have here, all you have to do is to see, just visually see, what is the difference of that number from 100. So 96 is 4 less than 100. 91 is 9 less than 100, right? So all you have to do is do just one cross addition. So 96 minus 9 is 87. 91 minus 4 is also 87. So you can do one of them. You don't need to do both. So 91 minus 4 is 87. You straight away write 87 and you multiply these two numbers, minus 4 and minus 9, which becomes 36. So 8736. I didn't need to do anything. Make sense?
So can you please repeat once again?
Yes. So 96 into 91. We started off with this, right? So you can do this with numbers which are close to 100. I'll show you a different technique which you have to follow for other numbers. So if numbers are close to 100, then what you do is see how close they are to 100. So 96 means it is 4 less than 100. So minus 4. Clear? 91 means it is 9 less than 100. Sorry? 91 means it is 9 less than 100, right?
Yes, sir.
So now just add the two numbers in a cross manner. So 91 minus 4 is 87, right? 91 minus 4 is 87. You can also do the other way around. 96 minus 9 is also 87. So you can do anyway. Doesn't matter. So 87 and then multiply these two. So minus 4 into minus 9 is 26. Right?
Okay.
So let's take another example. Let's say we have 88 into 94. Right?
Yes.
So what do we do? 88 is how much less than 100? 12.
12.
94 is 6 less than 100. So I take this. 88 minus 6 is 82. And I multiply these two. Right? So 8, 2, 7, 2.
72.
Clear?
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Okay. We can also do this with numbers which are greater than 100 also. I just showed you less than 100. We can try it with numbers greater than 100. So let's say I have 102 into 109. Right? So same logic applies. What is the difference from 100? So from 100 this is plus 2 and this is plus 9. Right? So I just do a cross addition. So 111. If I do this, this will also be 111. Right? So 111 and I multiply these two. 9 into 2 is 18. right? You getting the point?
Yes, sir.
Okay.
Yes, sir.
What happens if one number is greater than 100, the other is less than 100? So the logic remains the same. So let's say 107 into 91. Okay. So this is plus 7. This is minus 9.
Yes.
Right. So again I do a cross. So this becomes 98. Okay. And I will have to take the product of this. Now the product of this is minus 63. Okay. So there we have to be a little careful. So what we do is we put 2 zeros and we do a minus 63 here. So 9737. Right?
Okay.
So this is again a very, very effective method because it saves a lot of time. Right? Now let us look at the other method, which is a generic method for any number. Right? Let's say I want to multiply 54 into 67. How do I do that? So if I do it normally, I have to do 54 into 67, then 7 fours are 28, 7 fives are 35, and 2 37, and then 6 fours are 24, 32, and then I have to add all of this, and I get this, right? But there is a shortcut to this. The shortcut is 54 into 67. We will do it in 2 steps, okay, instead of 3. So what we do is we first multiply these two numbers, 5 and 6, 30, right? Then we do a cross multiplication, 6 into 4 plus 5 into 7. So 5 into 7 is 35 plus 24 is 59, right? So we write 59 like this, right? And finally we do a multiplication of 7 into 4, which is 28. We write 28 like this, and we add this. So 8, 9 and 2, 11, 6, 3. Clear?
Yes, sir.
This is actually, again, very, very effective for larger numbers. Let's try it with a slightly larger number. So let's say we have 186 multiplied by 238. How will we do? So again, the logic is the same. So first multiply 2 into 1, that is 2, right? Next, multiply 2 into 6, which is 12, plus 8 into 1 is 8, which is 20, plus 8 into 3, which is 24, which is 44. So we write 44 like this, right? We write 44 like this. Okay? And then
Okay.
We do 3 into 6 plus 8 into 8. 3 into 6 is 18, and 8 into 8 is 64, right? Shall I repeat this? Start from
Yes, sir.
the beginning. 186 into 238. Step 1. We multiply 2 and 1. Right?
Yes.
We multiply 2 and 1. So we write 2. Right?
Okay.
We write 2. Okay, next we go stepwise. So we multiply 2 into 8 and 1 into 3. How much is that? What is 2 into 8? 2 into 8? 16, right?
So 16.
Plus 1 into 3 is 19.
3.
3, 19.
Right?
Yes.
16 plus 3, 19. So we write 19. Right? Next, we cross multiply 2 with 6, 1 with 8, and 8 with 3. So 2 into 6 is 12, plus 8 is 20, plus 24 is 44. Right? Next, we go to 3. 3 into 6 plus 8 into 8, which is 18 plus 64. That is 82. Right? And last is 6 into 8, which is 48. Right? So now just add all of this. 8, 6, 2, 4, 4. Okay?
Yes, sir.
So this again is a big time saver in multiplication of large numbers. Big time saver. Right? So anyway, I'm going to send you the video so you can go through it again and try it yourself. Okay? Okay. Let's move to another interesting thing that comes very often in the exams. So this is about squares, right? And first we'll do squares of numbers with 1 only. Okay. So what is 11 square?
1 to 1.
What is 111 square?
So, one, 2, 3, 2, 1.
What is 1111 square?
So 1, 2, 3, 4, 3, 2, 1.
Sorry?
1, 2, 3, 4, 3, 2, 1.
Correct. So this is called the Pythagorean triangle. Okay. So what we do is we see how many ones are there, and we just write 1, 2, 3, 4 up to the number of ones, and then in the reverse order. So if it is 1, 2, 3, 4, 5, 6, 7 square, it would be 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3.
6, 5, 4.
Oh.
1, 2, 3, 4, 5, 6, 7, because there are 7 ones, and then count down 6, 5, 4, 3, 2, 1.
Okay.
Okay? Clear?
Yes, sir. Yes.
Okay. Next, we'll do this for squares with 3, number 3. So what is 3 square?
9.
9. What is 33 square?
1089.
What is 333 square? Okay. Let me tell you the rule here. So whenever you have numbers with 3 like this, square, you take the last one, 3. What is 3 square? 3 square is 9, right?
Yes.
We write it as 0, 9. Okay? We write it as 0, 9, not 9. 0, 9. Okay? And see how many 3's are there before that. So there are 2 3's here. So just
Yes.
put 2 spaces here and 2 spaces here. Okay?
Okay.
And write as many 8's as the number of places here, right? And as many 1's as the number of places here. Did you get it?
Yes, yes.
So let's say 3 3 3 3 3 square. So I'll take the class 3, 0 and 9. So I have 4 more 3's. So 1 2 3 4, 1 2 3 4. So I fill this with 8 and I fill this with 1. Clear?
Yes, sir. Clear.
Okay. Next we do this for 5. Numbers with 5. So 5 square is 25. What is 55 square?
Three 3025.
Sorry?
3025.
3025. Right. So, which means, how do we do this? What is the rule here?
5 square and 5 into 6.
So for 5, the rule is that this 5, just square it, so write 25, and this 5 multiply by the next number. So 5 into 6 is 30, so this becomes 30. Right? So similarly, 555 square will be 25, and this one would be 55 into 56. Right? So 55 into 56 means 55 into 55 plus 55, right? And 55 into 55 is 3025 plus 55, which is 3080.
Oh.
Yes.
Yes, sir.
Okay. Now, one second. Okay. Now let us look at another type of problem which comes very often. So what is we'll talk about remainders. Everyone understands what a remainder is?
Yes, sir.
Okay. So remainder is, suppose I divide, let's say 8 divided by 5, I get 1 as the quotient plus 3 as the remainder,
Remainder.
right? So tell me, what is the remainder when 17 is divided by 19? What is the remainder? Seventeen by 19 remainder. It will be 17, right? Correct.
Yes.
Remainder will be 17, right?
Yes.
What is the remainder when 17 square is divided by 19? So all of you would be doing calculation like 17 into 17, that is 289 divided by 19. You're doing this, right? Hello?
Yes, sir.
Yes, sir.
So this is the normal way that we do it, but we were not taught in schools that there is another way to deal with remainders. So when I divide 8 by 5, I can write 8 as 5 into 1 plus 3, right? This is what you do. I can also write 8 as 5 into 2 minus 2, right? Can I do this?
Yes.
The reason why I'm doing this is because I want to show you the concept of negative remainder and how effective it is, right? So if I do this, then my remainder is minus 2, okay? So that means if I divide 17 by 19, the remainder is either plus 17 or minus 2, right? Because I can write 17 as 19 into 1 minus 2, right? So
Yes, sir.
when I say what would be the remainder of 17 square by 19, the remainder of this is equal to the remainder of 17 by 19 whole square. And if I take the negative value here, so remainder of 17 by 19 is minus 2 whole square, which is plus 4. So you work this out. You do this 289 by 19. This would be 1, 5 plus 4 remainder. Correct?
Yes.
289 is 15 into 19 plus 4. So remainder is 4. But I did not do any of this. I just used this concept to bring out the remainder directly. Right? Now tell me, what would be the remainder when 17 to the power 5 is divided by 19?
Thirty-two.
Sorry?
13.
What is the remainder when 17 to the power 5 is divided by 19?
Sir, is it 13?
30 was saying, right? Let's see.
13, sir. 13, sir. 1, 3.
1, 3. Okay. Let's see. Anyone else? Anyone else? Okay. It is not 13. So we do the same thing. So remainder of 17 to the power 5 by 19 is equal to remainder of 17 by 19 whole to the power 5, right? So this is minus 2 to the power 5, which is minus 32, right? Now, be careful when you're dealing with negative numbers, negative remainders, right? So now minus 32 divided by 19 will give me a remainder of minus 13, not plus 13. Yeah? So when you are having a remainder of
Yes.
minus 13, you have to subtract it from the divisor itself. So 19 minus 13, which is 6, would be the remainder. Is it clear?
Yes, sir.
Okay, let us take another small example. Let's say, what would be the remainder when we divide 23 by 26? Minus 3, right? Minus 3, correct?
Yes.
So if I do 23 cubed by 26, what would be the remainder?
$25.
Correct. Got it? So minus, this would be minus 3 whole cube, which is minus 27 by 26, that is minus 1. So 26 minus 1 is 25. Yeah. So this is the way that you can use the concept of negative remainder, and I'll show you one more um, very easy problem that comes in many competitive exams where you need this concept. So tell me the smallest number which gives a remainder of 4 when divided by 5, 3 when divided by 4, and 5 when divided by 6. What is the number?
First one is 9, second one is 7, and third one is 11.
One number. I need one number which gives all of this. Just one number and the smallest one.
Six 93.
Sorry?
693.
693. 693.
Yes. No, no. No, no, it's not.
693 divided by 5 will give a remainder of 3, not 4. Okay. Let me give you a hint. Again, we'll use the concept of negative remainder. Now, if I would have said that, just forget this for the moment. Let's say, tell me the smallest number which gives a remainder of 1 when divided by 5, 1 when divided by 6, and 1 when divided by 4. What would be the number? What is the smallest number which is divisible by 4, 5 and 6? Sorry?
60. 60.
60, correct. So, what would be the smallest number which will give this?
Six, by doing LCM of taking LCM of 6, 7 and 5, it is not
61, because this is a common remainder for all three. So I find the LCM and I add 1. 61 is the lowest number that will give me 1, 1, 1 for 4, 5 and 6. Right? Correct? You understand this, right?
So can you please repeat?
Yeah, sure. So, okay, let me start again. So what is the smallest number which is exactly divisible by 4, 5, 6? This you all got. So this is 60. And how did you get 60? Because this is 2 square, this is 5,
Yes.
and this is 2 into 3, right? So I take the highest powers of all the factors. So 4 into 5 into 3, that is 60. Correct? This is how we found the smallest number which is divisible by 4, 5 and 6. Right?
Yes.
Now, what is the smallest number which will give 1 as remainder for all these numbers? So that will be 60 plus 1. 61 divided by 5 is also remainder 1, by 6 is remainder 1, by 4 is remainder 1.
Oh,
Right?
okay.
Clear?
Yes.
So if these remainders are same, then this number will be added. Right?
Yes.
So this is the hint. Now tell me, what will be the number which will give 4 when divided by 5, 3 when divided by 4 and 5 when divided by 6? So 4 can be written as 5 into 1 minus 1.
Yes.
3 can be written as 4 into 1 minus 1.
Yes.
5 can be written as 6 into 1 minus 1.
Yes.
This is the common remainder when I'm dividing by 4, 5 and 6. Right?
59.
Correct. 59. So all I have to do is get the LCM of this, which is 60 and minus 1, 59. So you understand the concept of negative remainder, why it is so important? Because in competitive exams, you will definitely get questions like these, either in terms of powers of numbers or LCM like this. Okay, so where you have to use the concept of negative negative remainder. And how would you understand? You would have to see the difference of these two. 4 minus 5 is minus 1.
Minus 1. Yes.
3 minus 4 is minus 1. 5 minus 6 is minus 1. That's it. So now I can clearly see that I have a negative remainder common across all three. Clear?
Yes.
Okay. Now let us look at some more stuff which is very, very common in all competitive exams, right? So we will first cover the concept of cubes. What would be the value of 24 cube? Please turn off your videos because it slows the internet down. We don't need videos. What is the value of 24 cube? So we normally do it like this: 24 into 24 into 24. So which is 576 into 24, and then we calculate using the method that I showed you, right? But instead of doing that, there is a very simple way to do this. What we do is we look at the first number. What is that? 2, right? 2 whole cube, which is 8. We write 8,
8.
right? We look at the last number, 4 whole cube. How much is that? What is 4 cube?
256.
4 cube,
Oh, sorry. 64.
64. So we write 64. Okay. Now, what we'll do is we take the square of the first number, multiply with the second number. So 2 square is 4 into 4 is 16, right?
Yes.
2 square into 4, that is 16. And then I take the square of this and multiply with the first number. So 4 square into 2, which is 32, right?
Yes.
And then I just double these two numbers. So I write 32 here, I write 64 here. And then I will add. So 64 means 4 comes here, 6 carries over here, right? 64 plus 6 is 70 plus 32 is 102. So 2 comes here, 10 carries over here. 32 plus 10 is 42 and 16 is 58. 8 comes here, 5 comes here. And 8 plus 5 is 13.
13.
Shall I repeat this?
So I understand.
Shall I repeat this?
So I understood.
Okay. Now, let me tell you one thing. If you have a number starting with 1, for example, 19 cube, this is easier. Okay. So here what we do is we write 1, right? We write 9. We write 9 square, which is 81, right? And we write 729, right? And we just double the numbers in the middle, so 18 and 162, and then we do the same thing. So 9 and 72, and then add all of this, whatever you get, carry over, add, carry over, add. But what I showed you is a more generic method, so that method works here as well.
Okay.
So this is how you can very quickly calculate cube of any number. Okay. Now.
Okay, sir.
Now we will talk about square roots. Okay. We'll talk about square
Yes.
roots. Now, what is the square root of 27?
Three root 3.
Sorry?
3 root 3.
Tell me the value.
So 5.19.
5.19, correct. Okay. So there's a very simple way of getting this. So look at the number 27. What is the square just less than that? 5, right? And 5 square is 25, right? Right?
Yes. Yes, sir.
So 5 square is 25, so I write 5, right? Point. Or not point, sorry. 5, and then I take the difference. 27 minus 25 is 2, right? Divided by double of this number, which is 10. That is equal to 5.2. Let's try this with any other number. Root over 41.
Six point five
6.5.
6.4. 6.41.
Okay, so we'll follow the method that I just showed you. So the square that is less than 41 is 36, so we write 6, and the difference of 41 from 36 is 5, and we take the double of 6, which is 12. So 6 and 5 by 12, that is equal to 6.4 and 1. Clear? This gives you a very close approximation of the actual number.
So can you please repeat once more?
Sure. So root 41, okay? What is the square just less than 41?
It's 36, sir.
36. And what is the square root of 36?
6.
6. So we write 6. And then take the difference of 36 and 41. How much is that?
6.
41 minus 36 is?
So it's 5.
5. Divided by double of the number that you've written, which is 12.
That's 12. Yes, sir.
So this is 6.41.
Okay.
Clear?
Got it.
Sorry?
Got it.
Okay. So we did cube, we did square root. Now let us look at cube root. And we'll look at only perfect cube roots. Okay, we'll not get into fractions because that is not possible by shortcuts. So let's say I have a number 13824 and I want to find the cube root of this. Okay, before I get into this, let us understand how the cubes work. So what is 0 cube? 0 cube is 0.
0.
1 cube is 1. What is 2 cube? 8.
8.
3 cube? 7.
27.
we just take the last number, right? It's 27, but we'll take the last number, right?
Okay.
4 cube, 4.
4,
5 cube, 5.
5,
6 cube, 6.
6,
7 cube, 3. 8 cube, 2. 9 cube, 9. This is how it works. I'm taking the last digit. Like 27, I'm taking 7, right? I'm just looking at the last digits. Right?
yes,
So, for 0, 1, 4, 5, and 6 and 9. So, for these 6 numbers, the last digit would be the same. 0, 1, 4, 5, 6 and 9. Correct? Correct?
yes,
And for 2, 3, 7 and 8, there is a pattern. So 2 cube will give you 8. 8 cube will give you 2. Look at this 2. Right?
Yes, sir.
3 cube will give you 7. 7 cube will give you 3. Correct?
Yes, sir.
So
Yes, sir.
why did I do this? Because I will look at the last number and decide the last digit. So the last number is 4 here.
Okay.
What would be the last digit?
So it will be 4.
It will be 4 for sure. Now, because we are taking cube root, we will ignore 3 numbers from the right and we will look at the rest of the numbers, which is 13. What is the cube that is less than 13? Cube less than 13.
2, sir.
Answer is 24.
No, sir.
Got it? Understood?
So can you repeat?
Yeah, sure. So I looked at 13824, right? 13824. So I looked at the last number or the last digit, right? So which is 4. What gives me 4? Only 4, right? So the last digit will be definitely 4,
Yes.
right?
Yes, sir.
And since we are taking a cube root, we will ignore 3 numbers from the right. 3 numbers from the right. Ignore. Okay? So we forget about these 3. We look at the rest of the numbers. 1, 3. So 13. What is the cube less than 13? What is the cube less than 13?
8. 8.
8, which is 2 cube. So therefore, the number digit will be 2. Clear?
Yes, sir.
Let us take another example so that you guys do and tell me whether it's clear or not. So let's say we have a number 97336. What would be the cube root of this?
It is 96.
Hmm?
96.
96. How did you get
Sorry.
96?
Sorry,
36.
36. 36.
36. How did you get 36?
Yes, sir. Sir, last digit is 6. So It is perfectly cube of 6, that is 6. And if we ignore 3 numbers from the right, then we get 97. Then 91 is a perfectly cube number.
Perfect cube less than 97. What is that?
81.
No, 81 is not a cube. It's a square.
Yes, sir.
So you have to remember these things. 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, right? So at
That is
least
4.
this you should remember.
4, 6.
64.
So 64 is a cube which is less than 97. So therefore 4, 46,
4, 6.
right?
Yes, sir.
If I have 50653,
3.
50653,
37. 37.
37, perfect. So because this is 3, so therefore it would be 7. Last digit would be 7. And ignore the 3 digit. We have 50. Cube less than 50 is 27, which means 3. Clear?
Yes, sir.
So can you please repeat?
Sure. So 50653, right? So first
Yes.
we'll look at the last number, only the last number, which is 3. Now you look at all these numbers and tell me which number when cubed gives 3 as the last digit.
7.
7. This is the only number that will give 3 as the last digit. So the last digit would be 7,
Okay.
right? Now next step,
Yes.
we ignore the 3 numbers. Look at
Okay.
only 50 and we try to find the perfect cube less than 50. What is that? What is the perfect cube less than 50?
27.
27.
27.
And 3 cube is 27. So that means 3 will come here.
Okay.
Clear?
Yes.
Okay. So we'll wind up here for today. We'll come back with next sessions and all that. But before we wind up, I want to understand, did you guys learn anything which you feel would help you in your competitive exams,
So obviously,
right? Because let me tell you that in competitive exam, as you all know, time is the key, because we know the questions. If we are given
yes.
sufficient time, we can crack all the papers, right? But the
Yes.
problem that we
Yes.
encounter is we run short of time, right? So and that is the
Yes.
pattern with any competitive exam, because it's an elimination round, right? So we
Yes.
need to definitely understand and learn tricks and tips and tricks on how we can speed up our calculations. Because remember one thing, the moment you write something and try to calculate by writing, you are consuming time. So
Yes.
the less you can write and the less you can follow these techniques, the more that you can follow these techniques will help you speed up your calculation. That's the only objective, right? I'm not going to teach you anything that you don't know, right? Subtraction, multiplication, root, square root, everyone knows, but these are techniques which definitely would help you to do things very quickly,
Yes, obviously.
right? So
Yes.
thanks a lot, and we'll announce the next class.
Okay. Okay.
Any last questions from anyone before we wind up?
Yes, sir.
Tell me.
So can you please repeat the square root of 41?
Oh, square root of 41. Sure.
Thank you.
See, when we have square root of 41, right, we first look at
Yes.
the number 41 itself.
Okay.
What is the perfect square
Less than 41.
less than 41? What is the perfect square?
36.
36. So square root of 36 is 6 because
Yes.
I'm taking square root.
Yes.
So 6. And then what is the difference between 36 and 41?
5.
5 divided by double of whatever value I have written here.
12.
6 into 2, 12. That's it. So this is
Yes.
6.41. If you do this division,
Oh.
it will be 0.41.
Okay.
Similarly, you can do anything. Root over 85, right? So this would be how much?
81 and 9.
9, correct?
81 to 4.
Correct.
4 by 16.
4 by
18.
18.
by
18.
So we can simplify this 2 by 9. So 9.2.
0.02.
0.2. Yes, sir.
2 by 9 is 0.2.
Okay. Okay.
Clear?
Thank you, sir. Yes.
Clear? Okay. Any other doubts
Yes,
from
sir.
anyone? Any other doubts? Okay. Okay, we'll wind up for today. I'll share the video on the Skype itself, so you can download it from there. Okay.
Yes, sir. Thank you.
Okay. Thank you all. Have a nice day. Bye.
Thank you, sir.
Thank you, sir.